Hello, ladies and gentlemen. Welcome to Lesson 3-4 assignment. Please remember that when we're doing this assignment, that you should be taking notes on the work that I'm doing. And also remember that if you only write down what is seen, you will not get credit for this. You must be taking notes on this. Now, you can take it on this paper, or you can take it on a separate sheet of paper. But remember, I'm going through the problem and writing down the answers. Some of the answers are very incomplete because I won't write the sentences. That's what your job is. Okay? So make sure you're listening carefully as we go through the assignment. 3-4 is a culmination or a completion of the chapter. This unit requires you to use everything in one. So now we start talking about a little bit more complex problem. As you can see that it's 2 paragraphs long. Okay. And it starts out with Dean and Emilio are collecting used children's books for a donation drive. Dean decides that he will donate his books to the community outreach programs. Emilio will donate his books between organizations, the city library, and Sunrise Elementary School. Now, notice you've already got 2 different problems. Okay, and when we read the rest of this, as we start getting into the numbers, you're going to have to institute something called chunking. Okay, chunking means when you read a piece of information, you then do that piece of information. In other words, we'll go through this one and I will chunk it with you. It says, Dean donates 50 of his own childhood books. So he's giving 50 of them. So that would be plus 50. Okay? At the start of the drive, he also gets a local pizzeria to match the total number of books he collects for the donation drive. So that means whatever he collects will be multiplied by what? Correct. So you have whatever he collects, and then it gets multiplied by 2. Okay, so we multiply by 2. Remember, we put multiplication in parentheses, so you can just put parentheses 2. Excuse me. Right. Emilio decides that he will donate the first 25 books he collects. Now, this is a different person. So he's collecting the first 25 to the city library. Okay. And then the rest of the books he collects will go to Sunrise Elementary School. He also convinces the local score to triple the number. So Emilio's amount is multiplied by 3. Okay? His amount is multiplied by 3. Whereas in problem 1, in this one right here, this first one that they're talking about, he's collecting all the books plus 50 of his own and multiplying it by 2. In the elementary school, they're talking about him donating the first 25, and then whatever else is collected, he's multiplying by 3. All right, so these are going to look a little different than the other problems that we've done. We're going to write a linear function to represent how many books Dean and the pizzeria will donate to the community outreach program. Okay, then decide the function in terms of increasing, decreasing, and continuous or discrete. All right, so here we go. We know that Dean, and I'm just going to call him D of X. Okay, we're going to go D of X. Not DMX, D of X. Okay, and we know that he's collecting books, plus he's giving 50 of his own. So we don't know how many books he's collecting, but we know he's giving 50 of his own. So whatever books he collects, he's adding 50 to. But then what is the local pizzeria doing? Whatever that is, they're going to what? Correct. They're going to multiply it by 2. So we can leave this function like this, or some of you realize that, hey, I can distribute this. Yes, you can. Either one of them is okay. So we'll put the or, and you practice the distribution part of that. And then I'll tell you what the answer is. Correct, you'd have d of x, remember we're writing this in function notation, equals, and then when you distribute it, you should get 2x plus 100. Right, that's because you multiply the 2 times the x and the 2 times the 50. All right, so that would be what Dean donates. Okay, now we're going to look at Amelia. Okay, as I move this up. And you have to remember the words tell me how I'm writing the problem. These are not easy. It takes a lot of getting used to. You have to be looking for context clues and hints. And you have to read and chunk. Remember, chunking is taking pieces of the problem at a time. Now in this next one, when we're looking at it, it says that he's going to take out the first 25 books and give them somewhere else. Okay, so he's collecting books, but the first 25 he collects, he's going to give away to one specific charity. Okay, when you do that, when you give something away, it's minus, and that's what this is. This would be minus 25. So he's going to collect books, and he's going to minus 25. All right. The first 25 will go away. Now this problem is a little bit different. We'll label it E for Emilio, X. And remember, we're using the same variable only because they're all books. His deal isn't that he's going to multiply the amount of books collected by 3, like here. They were taking the total and doubling it. He convinces the local store owner to triple the total number of books he collects. So that means he's tripling before minusing the 25. So whatever books he collects, the store owner is going to triple. And then he's going to subtract the first 25 books of what he sold. Whereas in this problem, what he collected was added by 50 because this person was contributing. He was giving books away. He was giving his books away. Whereas in this problem, he's giving away the first 25 books. Notice, this one is what we call a quantity problem. Why? Because it has parentheses. It has a different amount. Whereas in this one, we're just subtracting from the total. Okay? All right, so then we write the sentences. So the function, is it increasing or decreasing? And you should tell me for both of these that they would be what? Increasing. Why are they increasing? Because we look at the slope. And where's the slope or rate of change? Correct, it's the coefficient in front of x. Now remember, coefficient is a number in front of the variable. So in this one, it's 2. Which means it's positive. In this one, it's 3, which means it's positive. Okay. Now, are these functions discrete or continuous? And who remembers? Hopefully you don't forget these words because we're having an exam and you're going to have to know everything up to this point. Can't forget things. So what is the difference between discrete and continuous? Continuous is that you can have pieces or parts. Discrete must be whole numbers. Correct. So can we have half a book? Well, physically you could rip a book in half, but I'm not sure if anybody's going to want to be able to read it. Okay. You can only have whole books. So this has to be a discrete function. We can't have pieces, right? And then we have to look at what would be rates of change. Which one has a higher rate of change? That's the problem C here. So we're comparing the rate of change and y-intercept for Emilio's function and Dean's function. And what should you notice? Okay. Who's going to start out with more books? Correct. Dean is going to start out with more books. He'll start out with 100. Will Emilio? No, Emilio is starting in the negative because he's given 25 of those away. But who's collecting books or getting books at a higher rate of change? Correct. Emilio is getting them at a higher rate of change, where Dean is collecting 2 books. Emilio is collecting 3 times the books. Okay, so it's a higher rate of change. All right, so that means there's at least 100 books that Dean will start with, right? But he's not going to collect as many right away. Whereas Emilio is going to be collecting 3 times the amount of books, but he's short 25 because he's giving the first 25 away to a different charity. All right, so now let's go look over at D, and you should see you've got plenty of room to write those answers. So they're talking about compare the rate of change and the y-intercept between the 2 functions. All right, so let's move over. Don't want to make you dizzy. We go to the last 3 questions. Well, no, they're not the last 3 questions. We got a backside yet. Okay, so do the values in the 2 functions mean the exact same thing? Well, what do the values in the functions mean? Okay, and the answer would be no. All the values are not the same. Why? Because you have 2 different people doing similar things. They're not doing the exact same thing. Okay. Now, X does stand for books in both of them, but the X in the first function is the number of books Dean collects, whereas the X in the second function is the number of books Emilio collects. Notice, Dean will collect books, Emilio will collect books. But Dean's books don't count for Emilio, and Emilio's don't count for Dean's. So in other words, X represents the amount of books collected. But in the first problem, the reason why the functions aren't specific is because Dean is collecting an amount and Emilio is collecting an amount. They're 2 independent of each other. All right? Dean's books represents the numbers that he will donate. Emilio's function represents the total amount of books that he will be able to donate to the school. Remember, he's donating to 2 different places. So even though the equations look similar, they do represent 2 independent functions. Right? They are independent of each other. Whatever Dean collects doesn't have any influence on what Emilio collects, and whatever Emilio collects has absolutely nothing to do with Dean's. Okay? At question E. Dean and Emilio, who are both members of the National Honor Society, decide to combine their donation amounts and use these totals for their year-end service project. Predict how many times more books Dean and Emilio will get on average on top of what they collect if they combine their efforts. So we would combine their efforts. So who could tell me what you would actually do if you wanted to combine their efforts? Correct. We'll add their functions. So if we added their functions, it would look like 2x plus 100, okay, because that's what the one Dean's function was, plus 3x minus 25. They're combining what the 2 of them are doing. So let's look. Now, the key word here that catches everybody is the fact that they're going to combine it, but they want to know on average. Okay? So, we're not just combining them, but they want to know what their average rate of change would be. So not only do you have to add them together, you then have to do what? Divide by 2. Now, why are we dividing by 2? Well, you find averages by adding the numbers you have and then dividing by how many numbers you added. So if you had 10 tests, you would add the score for all of your 10 tests together, and then you divide by 10. Well, here, we're taking an average because we're adding together the two amounts, the two functions, and then dividing by 2 because there's 2 people. Okay? So this becomes 5x plus 75. And when you divide that by 2, you get 2.5. X plus, and here's the kicker, plus what? Yes, you're going to get a fraction here, or a decimal, right? You're going to get 37.5. Now remember, this is an average. Could you really end up with half a book? No. Nor could you end up with half a book here. But we're talking about an average now. So you're going to get an average of 2.5 times more books. Okay, because that's the rate of change. 2.5. All right. Last but not least, for this problem, it says, suppose Dean collects 30 books and Emilio collects triple the number of books Dean collects. Okay, so you're going to do one problem, and then that answer is going to be what you input for the second problem. Okay, so Dean collects 30 books. We're chunking. So now we're just going to do Dean's function with 30 books. So that means we have D of 30 equals 2 times 30 plus 50. All right. Oops, and I got this backwards. It's here. Okay, or some of you could have written it as 2 times 30 plus 100, depending on which form of the function you used. Or, okay, one of them or the other. And I apologize for this. I'll rewrite it. Okay. All right. So you would have written it one way or the other, depending on how you wrote your original function back in A. All right. So now we do the math. 50 plus 30 is 80 times 2 is 160. Okay. And of course, if you do it the other way, you still get the same answer. 2 times 30 is 60 plus 100 is 160. So you can see either way, you get the same answer, okay, because they are the same equation. Now, it says Emilio collects triple the number of books Dean collects. So now I'm going to take Dean's amount and plug it into Emilio's function, correct? Well, how many did Dean really collect? Dean collected how many? 30. This is where you got to be careful. Dean collected 30 books. Remember, X was the number of books he collected. That second number were the ones he donated. Remember? Okay, so how many did he actually collect? He collected 30. And 3 times 30 is 90. So now when I take Eric's function, it's of 90. Or Emilio's, I'm sorry. So Emilio's function is 90 books he collected. See, here we go. We had 30 books here. And then here it says, Emilio collects triple the number of books Dean collects. So if this was 30, we triple that, and we get Emilio's 90. Okay. So now we do Emilio's function, which would be 3 times 90 minus 25. And remember, we're minusing 25 because he's splitting his donating. He's donating 25 every time to one specific charity, and then the rest is going to another charity. All right, so now we do the math for this one. 3 times 90, correct, 270 minus 25, which gives us, correct, 245. Now remember, I haven't written any of the sentences for this. So this is how I know if you're doing it on your own, because you should be writing words. This is just the math, okay? So here we go. How many books did Dean collect? Dean collect 160 books. Emilio will collect 245 books. So together they would collect 405 books. All right. So now we end up flipping it over. And you have G, H, I, and J, because you don't want to forget about the back. All right. And it says, use your answer in part B to determine how many times more they will get on average if they combine their books. Okay. So that means if you take the two amounts that they got, 120 and 405, okay, on average, how many more times they will get. Okay, so let's look at what they get on average. It would be 405. What? Okay, so now we're going to work on the average. And when we look at this, you can see how we're going to do the average. The average is how many books we collected, or how many books total, divided by the number of books collected. And of course, one collected 30, the other collected 90. So that was 120 books total that we collected. So if we wanted to figure out the average rate, it's 405 total between the two of them, but we divided it by the number of books we donated, which was 120. So we could see what the rate of change is. Okay, and when you divide that, you get what? 3.375. So is that the same as our prediction? Our prediction was it was going to be about 2.5 times. It ended up being over 3 times, correct? So combining theirs gives them a lot higher rate of change. All right, so here we go. H, it says, let X represent the total number of books that Dean and Emilio collect. So now we're changing it. We're saying that X is the total number that both of them collect. And Emilio collects 3 times as many books as Dean. Okay, so Emilio collects one amount, and Dean collects one amount, and Emilio's amount is 3 more than that. Okay, so you have an amount, and then Emilio collects 3 times that amount. So when you add them together, you actually end up with 4, right? Because Dean's amount and 3 times Emilio's amount is 4 different amounts. All right, so when I go to do this function now, I've made it more complex. How have I made that more complex? Because now I've got 2 different rates. I have a rate that is happening to Dean's amount, and then I have a rate that's happening between Dean and Emilio. Okay? So yes, we're going to end up with fractions here. And this is when things get a little cuckoo. So you have Dean's amount. We'll start with Dean first. Dean collects 1 out of the 4 pieces. Now notice we had 4 pieces because Dean has 1 and Emilio collects 3 times that amount. When you add those together, you end up with 4 actual pieces. Okay, so Dean collects 1/4, whereas Emilio will collect 3/4. And then you still have their original function. So now you're just adding in the comparison between Dean and Emilio. So that was Emilio's. Remember, his was x minus 25. And 1/4 x plus 50. So now you have a rate of change in the problem. This is still that original problem. Okay. The only thing that's missing is we've now added a rate of change to compare between these two people. So the comparison between their two rates is Dean is 1/4 x and Emilio is 3/4 x. And that's the rate of change between the two of them. All right, so now we have an interesting scenario. Now let's see if we can add the two together with the rates of change. Okay, now this is not easy. Like I said, this is where you have to really keep your arithmetic straight. All right, so we'll start with Dean, and this is Dean's new rate of change. So we have Dean. Okay. So we have d of x, and that equals the expression I have written right here. And I'm going to distribute it. So hopefully you know that 2 times 1/4 is 2 times 1 divided by 4, which you should know is 1/2 x, or 0.5. But I would keep things as fractions. 2/4 is 1/2. Then 2 times 50, which is still 100. All right. Now I'm going to do the second half, which was Emilio's. And that was my e of x. And this function. So 3 times 3 is 9/4. 9/4 does not reduce. So we leave it as 9/4 x minus 25. And they have told us that now c of x will be adding these two together. So I've gone ahead and transformed and distributed. Now remember, this is the confusing part here because I'm adding in a rate of change. And I don't want to use the word add. I'm putting in a rate of change, an extra rate of change. So we had one originally that was the 2 and the 3, but now I'm putting in another rate of change because I'm not just getting the rate of books. I'm now telling you that there's a rate of books between the two. Okay, so that they're now related to each other, whereas before they were not. Now I'm telling you they are. Okay. So now we add those two together, and this is when, yes, the ugly math comes in. Now, if you wanted to, when you go back and you look at this, in order for you to add things together, they have to be like terms. So if you needed to, you could keep this as 2/4. Why do you keep that as 2/4? Because you can add 2/4 and 9/4. All right? Normally we would have to reduce that, but now we're going to add it back together. So we're going to keep this as 2/4 and 9/4. 2/4 x and 9/4 x can be added together. Remember, we're adding like terms. When you add the functions, you add like terms. Like terms have to have like variables or no variables. So 100 and -25 are like terms. 2/4 x and 9/4 x are like terms. So when you add 2/4 and 9/4, you get 11/4. Plus, the other one's easy. 100 minus 25 is 75. Now this is complex. This is going to take practice. Practice, practice. All right? And that's why you're going to use it with your skill practice. These do not get easier. Maybe a little easier. I saved the hard one to work with me. But remember, you want to take notes on this so that you know why you're putting the numbers where you are. The reason we use 2/4 is because we have 9/4 over here. Normally we would keep this as 1/2. You have to reduce your fractions. But we're adding these two together, and to add, you have to have like denominators. Okay, so if you started out with 4ths in the denominator, you know you're going to add them together, so keep the 4th there. May the 4th be with you. Okay, so explain the rate of change and y-intercept for the combined function in the terms of the problem. Meaning, they're going to start with how many books donated? 75, right? And then the rate of change is 11/4, which is that 3.375, if you were to change that to a decimal. Right? Or not? You check it. What is 11/4? Correct. When you add it together, it is different than the 3.375. Remember, the 3.375 was an average. So now we're talking specifically. We added them together. That means it's at 2.75. So they're able to donate 2.75 books for every one that they collect. Now, you gotta be real careful, because can you donate a part of a book? No. Okay, so the rate of change isn't a whole number. So that means you have to be very careful. You will get whole numbers only because whatever the books are, they increase. And you have to make sure you have whole numbers as your answer. So if I were to say, okay, 3 books were donated. Okay, so if we put 3 books into that problem, you'd have to be very careful, because now remember, this has absolutely nothing to do with this question. This is to check to see if people are listening. This answer has nothing to do with this question. This question is all words. Okay, the answer to this question right here, where it says explain the rate of change, that's this. Explain the y-intercept, which is that, in terms of the problem. And I've already said what that means. Okay, all right. But if we were to do this, you'd have 33 over 4 plus 75. Okay, so what is 33 divided by 4? I'll let you do it on your calculator. It's 8.25. So, did they collect 8.25 books? No. What would you have to do with that? They collected 8, right? Because you can't have pieces of book. Even if it was 8.75, they wouldn't have been able to collect 8.75 books. Okay? They would have collected 8. And then plus the 75 would tell you the amount of books they collected. Okay, so understanding what that function represents and how you would get your answers is also important, because this function was discrete. If this function was continuous, then 8.25 could be an answer. All right? So understanding what you're reading and how you're doing it are 2 key components to this problem. And we'll go over more of these types in class. On the test, this would probably only be 1 or 2 questions. But remember, we only have about 10 questions on a test anyway. All right. Good luck. We'll see you on Monday. We'll go over 3-3 skill practice, and 3-4 skill practice will be for homework, 3-3 and 3-4. But we'll go over the book work for 3-4 in class. Hopefully you will have had done the video. All right, bye.